Alright, this is going to be a blast, but basically what we're going to do is we're going to go through this entire quad 9 weeks work in 6 minutes 58 seconds. It's going to be rapid. You feel free to pause it, feel free to zoom in, whatever you need to do to make this work for you, but this is a massive amount of information coming pretty quickly, so be prepared, get ready on that pause button. Alright, this is Froyo's work from back in the day. So when factories are reacting on a large scale, chemists have choice of reaction pathways. Low atom economy means that waste byproducts are formed. It is better to reduce the amount of the byproduct. One way to improve the atom economy as a reaction is to find uses for the byproduct. Energy consumption, rate of reaction, raw materials, and the conditions needed to produce the high yield of the reaction reaching equilibrium must be considered. So factories, industry will make the best possible combination of factors, catalyst, temperature, pressure, concentration, and create the cheapest and most effective method for yield. Okay, continuous versus batch. Continuous processes where the reactants are constantly being created in reactors and products are removed. Batch processes are less automatic. Batch process, a small amount is made, apparatus is cleaned, then another small amount is made, similar to what is done in a lab conditions. So continuous processes need less people, more automated. The reactants are constantly going in, the products constantly coming out. Batch processes more people involved, constantly being stopped and started, so it takes more time than a continuous process. Alright, titrations next. Acid-alkali titrations are used to find the exact volume of an acid when neutralizing a specific volume of an alkali, or vice versa. End point is when it stops being acid and becomes an alkali, and vice versa. Measure from the bottom of the meniscus curve. Concentration in grams per decimeter cube is mass of solute in grams divided by volume of solution in DM3. Step 1, calculate the number of moles in the known solution. Step 2, use the balanced equation to work out the number of moles of an alkali reacted. And step 3, calculate the concentration of the solution. Okay, concentration. Concentration is mass of solute in grams divided by volume of solution in DM3. We got the mass in grams divided by concentration will get me the volume. Vice versa, you got the equation triangle there. Concentration in moles decimeter cubed is equal to number of moles in solute divided by number of solution volume of solution in DM3. The concentration of a solution is often given as number of moles and a solute dissolved in 1 DM3, which is equal to 1 litre. If the volume of the solution is given in CM3, convert it to DM3 by dividing by 1000. CM3 divided by 1000 equals my DM3. Okay, quick bit about hydrogen fuel cells. The strength of using them is how much the acid ionizes in a solution. Concentration is how much of acid there is in a set volume. Chemical cells store all their reactants, but fuel cells are supplied with fuel and oxygen from outside. Hydrogen, oxygen fuel cells use hydrogen and oxygen, obviously, water being the only product. Hydrogen and oxygen fuel with an electric motor are much quieter and need less maintenance than most other engines. Combustion engines, they do not, however, and also they do not produce carbon dioxide, major benefit to the environment. However, it is a byproduct when they are being made, so it's not carbon zero. Okay, the Haber process allows us to feed the global population. The Haber process is an industrial process used for producing ammonia from nitrogen and hydrogen using iron as a catalyst and a high temperature and a high pressure. Ammonia plus nitric acid gets me an ammonia nitrate, NH3 plus HNO3 gets me HN4NO3. Nitrogen, hydrogen react together to form, but it is a reversible reaction. Ammonia is used as a fertilizer. So you've got sulfur and plus air equals sulfur trioxide, plus the water gets me sulfuric acid. Down the bottom I've got natural gas, coal, plus water gets me hydrogen, air gets me the nitrogen, and then I get ammonia, then I get ammonia sulfate. Boom, done. Right, now we're looking at equilibrium. So Haber process does look the key idea about it is that it's an equilibrium reaction dynamic. It can go back and forth, so therefore reversible. So here we go. Things which affect equilibrium: the temperature, the catalyst, pressure, concentration. We want to favour the forward reaction, so we're going to try and get as much ammonia produced as possible. So we're making the temperature higher, increases the amount of energy particles have, causing more collisions and more chemical reactions. Increasing using a catalyst increases the speed of reaction without taking part. There can be reused and made into something new. So that catalyst does not take part of that. Pressure: the same amount of particles in a smaller space causes more collisions because there's less space, so they have to smash into each other more. Concentration: more of them means more reaction. However, when you start to produce smaller or larger molecules, that affects the concentration of either side, the forward or reverse reaction. So moves away from the reacting substance to the balanced equation. Big companies will choose the best reaction pathway to create the cheapest and most effective method, as we had talked about. So it's not always the hottest or the most concentrated or the most pressurized. Sometimes it's a perfect mix. Yields: theoretical yield is the maximum amount of product you should get from a reaction, considering that everything has been used. Example, baking. You want to put all of that recipe, all those ingredients into making all of that cake. All right, you want to use as much as you can. However, in real life, it doesn't always work like that. Sometimes you get stuff left on the spoon. Percentage yield is actual yield divided by theoretical yield times 100. Actual yield is the amount of product which you actually get. For example, some of the reactants could be left over on the container or spoon, or there could be a human error. Not all the reactants could have reacted. Now, in the situation with reversible reactions, is sometimes that yield is affected because it is reversed. Right, that was 9 weeks in 5 minutes. Thanks, bye.